Hello. Now we will solve a question covering Pearson's product movement correlation coefficient R. The following table shows the systolic blood pressures P and the age T years of 6 male patients at a medical clinic. Patients are shown as P1, P2, and P6. Years age are shown as T, 47, 2, and 61, and so on. And blood pressure is shown as letter P. Determine the value of Pearson's product movement correlation coefficient R for these data. Now we will use our TI. First we are hitting stat button, and then I've already input the data for the first column. Years, age of these 6 male persons on the first column, and P, blood pressure of these persons are shown at the second column, L2. And we have to first, since we will evaluate the R value, the diagnostic must on. Let's check. Yes, our diagnostic is on. Again, I'm hitting stat button. We entered these values. Now we will evaluate the R value. I'm entering the linear regression button. And then calculate. Now, as you see here, R value is, let me check it again. R value is 0.9459 and so on. And in this, our also, if we deal with our regression line, y is equal to ax plus b, and a is 1.05, and b value is 69.34, and so on. All of these data are found by using our TI. So if we write our R value is 0.9459 regarding three significant figures, 0.946. This is our answer for part A. And second part, interpret in context the value of R found in part A. Now we are able to write that there is a strong positive correlation between age and blood pressure. There is a strong positive correlation between age and blood pressure. Okay, now part B. The relationship between T, age, and P, blood pressure, can be modeled by the regression line of P on T with equation P is equal to A times T plus B. Find the equation of this regression line. Now, if P is equal to A times T plus B, at the previous part, we found that A is equal to 105,400 and B is equal to 69.347 and so on. So at the end, A is equal to 1.05 and B is equal to 69.3. And our regression line is P is equal to plus B. And at the end, this is our regression line P of regression line of P on T. Also look at these values. As you see here, after inputting our data, we found A as 1.054 and so on, B is equal to 69.34 and so on. A 50-year-old male patient enters the medical clinic for his appointment. Use the regression line equation from part B to predict this patient's systolic blood pressure. A 50-year-old male patient enters the medical clinic for his appointment. Now we will use our regression equation. P is 1.0543 times T plus B. We said that P is equal to A times T plus B. This is the A value, and B value is 69.347 and so on. Now the age of the new patient is 50, so we have to substitute T is equal to, we have to write T is equal to 50, and if we evaluate the P value, we will obtain 122.049, and so our answer will be, regarding three significant figures, our answer will be, our blood pressure will be 122 for this 50-year-old male patient. Now, the final part. A 16-year-old male patient enters the medical clinic for his appointment. Explain why the regression equation from part B should not be used to predict this patient's systolic blood pressure. Now, why we can't use this regression equation? Because the regression line should not be used because 16 years is an extrapolation for our investigation. This is the end of our question. And I hope we meet in the next video. See you.